Assalamualaikum and hi everyone, my name is Nida Nurisna binti Muhammad Zaid and I'm from CDCS 2513A. In this video, I will walk you through my cybersecurity threat monitoring dashboard. It's designed to provide a real-time insights into attack trends, protocol usage, severity levels, and geospatial threat distribution. So let's dive into how each section contributes to monitoring and mitigation. We put map in our dashboard and we also put bar chart to monitor login events. And there's also pie chart for threats and attacks. We also create bar chart for protocol breakdown by action and another bar chart for total action by service. And at the same time, we also use area chart to show top source organization. And then we have another pie chart for top block reports. And we also create line chart to show sudden spike in system activity. And last bar chart for top source countries attack. And lastly, we have indicators of compromise. So in this dashboard also, I can narrow the time frame to analyze a spike or filter by severity to focus on a high risk events. So here for example, I can narrow the timeline by filtering to 13 December 2023 and my dashboard and our dashboard will show all the information that our data had.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Izzati Azwa and I will explain for the monitoring phase. As for our dashboard, we have three panels that can monitor. The first one login, the second one protocol breakdown by action, and the third one is threat or attack. So for the first panel, how we visualize by using bar chart, and for the horizontal we use source IP and the vertical we use count of event. For this panel, we can see that we have 4 action: block, access, success and failure. And the from left, we can see the most count of event by the source IP. We can also see by action, by clicking the action. So for the second one, protocol breakdown by action, we virtualization by bar chart, but this time we use the bar orientation for horizontal, and for the vertical axis we use protocol, and the horizontal axis we use count of record. For this panel, we can see that DNS have the most count for allowed and also block. Okay, so for the last one, threat or attacks, we use bar chart to visualize, and we slice by event type. And we can see here that DDoS have the most attack, number of attack. The second one is normal, and the rest have the similar number of attacks. That's all from me. Thank you.
My name is Nur Alia binti Arifin, so I will continue with detection phase. First, I will explain about the monitor login events. From the visual data that we observe, there is multiple fail login attempts. The IP for 192.168.0.119 stand out with 4 failed attempts, this is the highest in the dataset, which is unusual. This pattern was detected using the dashboard built-in features and no custom rules were needed. So, the IP 192.168.0.119 is suspicious because it has the highest numbers of failed logins compared to the others. Repeated failures might mean someone is trying to guess the password or brute force login. This kind of behavior is common because it unauthorized access attempts. Sudden spike system activity, which is the dashboard show a clear spike in events on December 30, 2023 at 4. This pie chart show 100% of events are the same type, which is DDoS, and the pie chart is show the most attacks come from Malta, and the table show repeated high severity DDoS attacks from the same IP, which is 53.162.38.99, targeting the same IP, which is 171.25.193 and 77. So this show an unusual and concentrated attack. So the activity is suspicious because there is sudden jump in attack volume, and the same source IP and the same target IP appears many times, and all attacks are high severity and of the same type, which is DDoS, and the attacks all come from country Malta and target another country, which is Ecuador, and this look like a planned and repeated attack. Next incident is the access from unusual geographic regions. So this dashboard shows a map visualization named access from unusual geographic regions. It automatically flags 154 access events from areas not commonly accessed by normal users, but these red circles with the number 11 show the clusters of unusual activity are suspicious because the access come from unexpected location, areas far from the usual operation base. Users are normally based in Malaysia, so access from distant or unrelated regions could mean compromised credentials, and multiple unusual regions at the same time could indicate a botnet or attackers trying to form different IPs globally. The next incident is tracks of attacks breakdown. The pie chart show different types of tracks detected. So DDoS is the most common, which is making up 49.77% of all the events, and normal traffic is 26.91%, which is expected. So other tracks like SQL injection, phishing, ransomware, malware, and brute force. DDoS attacks are high risk because they aim to disrupt service and they form almost half of all the traffic. And ransomware and malware are known for causing serious data and financial loss. Phishing and SQL injection can be used for credential theft or unauthorized access. So all insights are based only on what's shown in the chart. No assumption about who launched the attacks or their intent. The threat types and their percentage are directly from the pie chart.
My name is Alirata Shasmi Shukri, and for the next part is investigation phase, and I'm going to present to you phase 1 ELK-based investigation. So we are going to focus on the right side panel, which is monitor login events. It will show the color-coded bar chart that has been categorized by its status of block, allowed, success, and failure. And we are going to focus on the block 1. As you can see here, there is multiple IP addresses that has been blocked to log in into the system, and then the IP address of 192.168.1.219 reaches the highest number of login events that has been blocked by the system. So we are going to use Kibana timeline to investigate more on this IP address. So for the next part, I'm going to show you how to implement the timeline in Kibana. So go to your menu bar and then search for the timeline under the security part, and then click on the untitled timeline to create a new one. And then we are going to filter out our data by using the KQL syntax. I'm going to use a field of source IP keyword equal to the IP address that we want to investigate, and then another field which is service keyword equal to check. And then I'm going to choose duration of last 1 year, and then refresh the page. As we can see on the screen, the multiple event that occurred on April 1st, 2025 has been done by this IP address that is display. So I'm going to explain to you what this message means. So on April 1st, 2025 at 12 p.m, the device with the IP 192.168.1.219 located in Malaysia has attempted to connect with the internal system at IP 192.168.1.1, and it used a FTP protocol to connect to the port 443, which is used for HTTPS. So the system can classify this as a threat, and the connection was blocked. I'm going to show you one example. On the same day, April 1st, 2025 at 9 p.m, the same IP address tried to log in into the same system, but the IP used the RDP protocol to connect with the port 389, the IP was tagged under the threat service, indicating that malicious or suspicious behavior. However, when the logs show that the action was allowed, it means that the attacker already bypassed the protection mechanism and was able to authenticate into the system. So this could raise concern and warrants further investigation, because the system allowed the suspicious IP to log in into the system. This could be caused because of misdetection, problem of the file protection, or even because of valid user login into the system from suspicious IP.
Assalamualaikum, my name is Dalil Haifa binti Nazri. For this presentation, I will walk you through an investigation involving 3 IP addresses. These IPs were found in our network logs and flagged as potentially suspicious. I analyzed each one using VirusTotal and then classified them based on whether they were actually threats or not. Let's go through them one by one. Firstly, we add the filter by selecting a field which is event severity is high and event type is malware. And then I selected IP address of 138.68.9.83. Then we copy this IP and search it on VirusTotal to check if it had been reported as malicious by any security vendors. Firstly, we add the filter by selecting a. So here is the result from VirusTotal. 4 out of 94 vendors flagged this IP as malicious. It was detected for malware, phishing, and suspicious activity. In our logs, this IP was involved in brute force login attempts. Since both VirusTotal and our own data flagged this IP, it is a true positive, which means it is a confirmed threat. Next, we do the same step as previous one, but for another IP address. For this one, I investigated 185.220.100.241, which was linked to suspicious encrypted traffic in our logs. Let's check what VirusTotal says about it. Next, we do the same step as previous one, but for another IP address. So this result is even more concerning. 6 security vendors flagged this IP as malicious. It is also listed as a Tor exit node, which is often used in ransomware or anonymous attacks. In our case, it appeared in connection logs during suspicious activity. Based on this, we can classify it as true positive. This is another confirmed malicious IP. Finally, I checked for the event severity is low, which is 104.244.42.129, which was found in our logs but didn't show signs of malicious behavior. Let's look at the results. As you can see, VirusTotal shows 0 detections, which means it is clean. The IP is owned by Twitter and there is no history of abuse or malicious use. Our logs didn't show any suspicious activity either. This makes it a true negative, which means it is a legitimate IP and not a threat. Lastly, here is a quick comparison of all 3 IPs. The first 2 IPs were both classified as true positives, meaning they are confirmed threats based on VirusTotal and log evidence. The third IP is a true negative, meaning it is a clean and safe, just a regular traffic from Twitter. To conclude, we successfully identified 2 malicious IPs and confirmed 1 safe IP. Using VirusTotal along with our logs helps improve our threat detection. My recommendation is to block or closely monitor the 2 malicious IPs. For safe IPs like the one from Twitter, we can whitelist them to reduce false alarm and keep the alert system accurate. That's all from me. Thank you.